Okay, so now we're going to delve into chapter one, which is an introductory chapter, which deals with what is chemistry and why do we study chemistry. So let us start off by defining what chemistry is. Chemistry is that science which deals with these things: the composition, structure, properties, and reactions of matter, and especially of atomic and molecular systems. So that's basically what is involved in chemistry. We're concerned with all these things, and in particular, we're not only concerned with observing changes that are taking place with substances, but we want to understand how these changes occur at the very microscopic level, at the level of atoms and molecules and small particles. So, at the heart of chemistry is matter. Matter, by the way, is anything that has mass and volume. Okay, so that's what matter is. And as I said before, in chemistry, we are concerned with several aspects of matter. We're concerned with the composition. In other words, we're concerned with the makeup in terms of the different substances, the different components that make up the one substance. We are concerned with the structure. In other words, how the different particles are put together to form the gross structure of the substance. We're concerned with the properties, and by properties, we mean the defining characteristics of a substance. So we're talking about things like smell, things like taste, color, the boiling point, the melting point, refractive indices, all those things that make a substance what it is. And then finally, and maybe more interestingly, we are concerned with the reactions that these substances will undergo. All right, and all these things are related to each other. The structure and composition are related to all those properties that we observe, including the reactions that we would observe a substance undergoing. So that's basically some introductory comments concerning chemistry, what chemistry is all about. Now, I want to take some time to talk about the scientific method because science, of course, requires a certain methodology involved, and that is true not only in chemistry, of course, but true in other sciences. So, what is the scientific method? It is the method or the process that scientists use to explain observations in nature. And it's a step by step process, all right? First of which is the observation. And this is where we actually identify the phenomena, recognizing it and stating it clearly. The second step is where we provide a tentative explanation for the observation, which would itself form a basis for further experimentation. And we call this in science a hypothesis. So the hypothesis is basically a reasonable guess or explanation for what we observe in the first step. And then the next step involves testing the hypothesis. Now, in the natural sciences, we do that by performing an experiment. This requires, of course, that the experiment is so designed such as to test the hypothesis. So therefore, basically, we try to set up the experiment so that if the hypothesis is not true, then it will fail the test. All right. If the hypothesis, if there is reconciliation between the hypothesis and the experimental result, then at best we can say is that the experimental data supports the hypothesis. So that's basically what happens in the experiment, and this is, I would say, the most difficult and challenging part of the scientific method because, of course, you have to take time to first design an experiment and then you have to actually perform the experiment. And usually that is a very labor intensive, time consuming exercise. Okay, so after performing the experiment, then what you'll find more often than not is that the data from the experiment, especially first time around, will not jive or will not reconcile with the original hypothesis. So what we have to do, therefore, is to change, modify, or in some cases, totally replace the hypothesis and put forward a new hypothesis which falls in line with the experimental data. And then we test that hypothesis with another experiment and we repeat those two steps until we have some harmony between the experimental data and the hypothesis. Now, when that happens, we end up calling the refined hypothesis a theory. So the theory is a bit different from the hypothesis because, as stated here, a theory is a model or explanation which is backed by the data that comes from the experiment. So that's a big difference between this theory and the hypothesis. The hypothesis is basically an explanation which is subject to testing, all right, to find out whether or not there is some validity to the hypothesis. But a theory is an explanation which is based on the weight of the evidence that has been established after testing previous hypotheses, refining it, and testing it again. All right? One thing I didn't mention, which is an important part of the scientific method, is a scientific law. The scientific law is basically a statement which basically covers what is observed when it comes to a particular phenomena. Sometimes the scientific law can be stated as a mathematical equation, but not always. Later on in chapter 10, I think, when we get to a discussion of gas laws, you're going to see where we can describe the behavior of gases, for example, based on mathematical relationships between two variables, let's say pressure and volume, all right? And basically that's what a scientific law is. It's a description of what is observed for which there are no exceptions. It does not explain anything. The role of explanation is the role of the theory. The scientific law basically says this is what will happen. Okay, so what I'm showing you here is basically a flowchart of the scientific method. So as I said before, you start off with your observations, you test you put forward a hypothesis to explain your observations, and then you test it with experimentation. As I said before, this process is repeated over and over again between hypothesis and experimentation so as to refine the hypothesis, so you have some correlation that you can establish between the experimental data and your refined hypothesis. So your refined hypothesis at this point becomes a theory. And let me just say this, which I probably should have mentioned before. Even when you end up with your theory, that theory may be widely accepted by the scientific community, but it is still subject to scrutiny, because somewhere on this planet you may have a scientist tinkering away in his lab or her lab testing the theory. And the history of science is such that it shows you that in some instances, even well-established theories that have been accepted widely by the scientific community, have been destroyed because of further data that has been established which counteracts the theory, all right? And this goes to show you that science is a dynamic field. There is no sacred cows in science, nothing that is not subject to questioning. Everything, even the most accepted theories, is subject to question, because that's the only way the theory can stand up to any scrutiny. Okay, so that's basically what is involved in the scientific method. So let me just recap some definitions here. Again, this is very important. I think it's worth reiterating this point. The difference between a hypothesis and a theory. A hypothesis is a tentative explanation of certain facts, and that forms a basis for further experimentation. All right, that's how you test the hypothesis to make sure that it is something worthy of acceptance, because you're testing to see if it falls in line with what the data says when the experimentation takes place. The theory, on the other hand, is what comes after continuous refinement of hypotheses with experimentation. All right, so basically the theory is an explanation that is backed by the evidence or the data arising from experimentation. So that's a difference between hypothesis and the theory. And then the law is a statement. It is not an explanation of any kind. It's basically a statement of what is observed in nature, to which no exceptions are known. All right, under, of course, the given conditions. And as stated down here, a law is not an explanation. So, you know, the reason why I'm stressing this is because very often, and even scientists do this, if, you know, a scientist or if a student is asked to explain something, some people, they go straight to the law. The law is not an explanation. The law is basically a descriptor of what is observed. The explanation would lie in the theory for the particular phenomena that is of interest. All right, so it's important that as a scientist, as a budding scientist, you understand the difference between these three terms. All right, and this is just another diagram, again highlighting the difference between the hypothesis versus the theory. The hypothesis is a tentative explanation of certain facts, while the theory is an explanation of general principles of certain phenomena. And here is the real difference between the two. The hypothesis provides a basis for further experimentation, while the theory has the weight of evidence or facts to support it. Okay, so with that out of the way, I want us to look at this example here, because believe it or not, in our everyday activities, we do actually apply the scientific method without even realizing it. So here's one situation. Let's say you want to play your favorite CD, all right? So you put your CD in the CD player and you press play, and what happens? The sound from the CD player skips, all right? So in the scientific method, we call that the observation, all right? That's what you observe. Now, you want to play your CD. You want to hear your music from your favorite CD. So you have to solve the problem. How do you get to hear your music? So you have to come up with a reasonable explanation as to why you observe what you observe. Why is it that the CD in the CD player is skipping? So, of course, there are two obvious reasons, possible reasons. One would be there's something wrong with the CD player, or there's something wrong with a CD. In other words, you have one of two hypotheses to work with. So the first hypothesis we're going to look at is the possibility that something is wrong with the CD player. In other words, the CD player is faulty. So now that we have this hypothesis to work with, the question now becomes, okay, so how do we test this hypothesis? Well, in this particular case, the test would be that you simply replace the CD, the original CD, with another one, and see if and observe what will happen. And what is shown here in this particular example is that when you replace the first CD with a second one, the second CD sounds okay, all right? So what you can conclude from doing that experiment is that there's nothing wrong with the CD player, all right? So that would be your theory in this process. Okay, but you still want to hear your CD, so therefore you move on now to the second hypothesis. And your second hypothesis is that, okay, there's nothing wrong with the CD player. That means that something is wrong with the CD. So again, you have to ask yourself, how would I test this particular hypothesis? So the experiment you conduct in this case is that you take your original CD and put it in another player, which we assume is functioning well. And then what you observe, according to this example, is that the sound still skips. So basically, your theory is that based on your experiments that you conducted, it is the original CD that has a defect. All right. So, this might seem as if it's a simple example, but it's actually a good example of the scientific method at work when it comes to problem solving. And this is important for you to recognize as budding scientists. Okay. So that's it for this first chapter. So until next time.